Alright, so in this example, we have a bathtub filled with 200 kilograms of water at 35 degrees Celsius. And to raise the temperature of the bath water, about 10 kilograms of water, 100 degrees C, is dumped into the bathtub. We want to know what the thermal equilibrium temperature is, and then what the net change in entropy of the system is. Alright, so I'm sinking in some more practice for a calorimetry problem. So we have the change of the cold water versus the change of the hot water. So we're going to take the mass times specific heat of water, temperature final minus the 35 degrees C, and then the mass of the hot water times the specific heat times the change in temperature for the hot water. And we get a thermal equilibrium temperature of 38.1 degrees Celsius. Now we want to find the net change in entropy of the system. And we have to remember, because we're dealing with changes in temperature, the first thing we need to do is integrate, making use of our mc dt formula divided by the temperature. So the change in entropy is going to be mass times the specific heat times the natural log of the temperature. We're evaluating from initial to final temperature. And it's the natural log because the integral of 1 over t is the natural log of t. So we have to, and this is what drives me nuts about entropy, it's like the change in entropy. So we're doing the change in entropy for the cold water and then the change in entropy for the hot water, and then we're adding that change together to get the ultimate change. And we do have to be careful here, because the entropy formula you have to use kelvins. So I've converted all of my temperature into Kelvin. So for the cold water, we're starting out at the 308 Kelvin, which is the same thing as the 35 degrees Celsius. And then we're going up to 38.1 degrees Celsius, or about a 311 Kelvin. And then for the hot water, we start at 373, and we end at the same point, the 311 Kelvin. So we find that the hot water, because it's decreasing in temperature, is going to lose a certain amount of entropy, and the colder water, because it's absorbing energy, is going to gain a certain amount of entropy or chaos. So the molecules are going to start moving around more. But the overall net change is positive, because remember, we always have to increase the entropy of the universe.